Hello, welcome back to Cinderella Math. Today I'll be doing a midterm study guide for a pre-calculus class. Um, this is like a pre-calculus kind of like dual enrollment college credit thing, but if you're just in a normal pre-calculus, it's still probably helpful for you as well. It will also have some trig on it, so if you want to grab your unit circle, feel free. Grab whatever calculator you are allowed to have. I will have Desmos running in a separate tab. But if you're not allowed Desmos and you are allowed a handheld, go ahead and grab that. This is 14 pages, this study guide. I scanned this from a tutoring student. Um, Unless I really get on a roll, I don't think I can do it in one sitting. So this will probably be like a part one, part two, maybe even a part three. We'll see. But I'll see how much I can do right now. So this is part one of a pre-calculus midterm study guide. I do not have an answer key, unfortunately, so sorry in advance for any, mistakes I make. It happens. We're all human, but I'll do my best. All right, let's just jump right in. It says graphing transformations. Given the graph of f of x below, graph the new function. All right, well, I know this is going to take it down to, right? And then this one inside with the x is your horizontal shift and it lies. So you would think -3 would take you to the left, but it doesn't. That's going to take us to the right. 3. And then a negation in the front will reflect us over the x-axis. Reflect over x-axis. Now, some people say the order that you do these matters, and some people say it doesn't. So that's a good question. I don't know if it truly does matter. You know what? Let me try to do it in the way that I actually just wrote those down. So, like the red, then the green, then the blue. And then I'll do it the opposite order and see if it makes any difference. There is a graph provided, but I'm going to graph it on the same graph as the original function. So I'm going to come down 1, 2, down 1, 2, down 1, 2, down 1, 2. Okay, there's the down 2. And now I'm going to come right 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. Okay, now I'm at the red. Okay. And now I'll just reflect over the x-axis. So 1, 2, 3, 4. 1, 2, 3, 4. 1, 1. That one will stay. And that'll be like that. All right. So it didn't actually fit on this one, but again, if there was another axis provided, I could have done. Okay. So I did the down 2, then the right 3, then the reflect. Let's see if we get the same answer if we do it in kind of the order given. So I'm going to reflect first now over the x-axis because that's what a negation in front does. So this will go here. Okay, there's just the reflection. Okay, now I'm going to go right 3. Okay, there's the right 3. And then I'm going to go down 2. So yeah, that is a different answer. Yeah, that's certainly different. And you can kind of see the next one, it says tell them in order. I'm gonna have to Google what is the order of transformations. Because I thought it didn't matter, but it certainly does. seeing a couple different things here. Well, I'm seeing like conflicting information. Like it doesn't, I'm seeing one thing that says do, this shifting first, and I'm seeing another that says do the reflecting first. Interesting. Okay, hold on a second. Let's go to Desmos. So we did negative x minus 3, negative 2. Okay. So let's just take x squared as an example. So then we would do negative x minus 3, oops, squared, and then we did minus 2. Oops. And then minus 2 as well, yeah? Let me make sure I got that right. I know we don't have x squared, but yeah, there we go. Okay. So their answer is more like the second one I had, where I flipped first, then scooched it. I know that's not a word. I'm being silly. Okay, let me just try something. So if I'm looking at the original, which is the red, if I went in the other order, down 2, so there, that would be the down 2, right? 1, 2, 3. And then flip over the, so let me do it. Let's do a flip first. So there's our flip. Right 3. 1, 2, 3. And then down 2. Okay, so it looks like we need to do it that way. So the second way I did it, let's go with that. So let's flip over the x-axis. Okay, so step 1, check. Let's take it right 3. Okay, check. And then down 2. Okay, so I would go with the blue. Final answer. There we go. All right, so let's do that again. That one's supposed to be in there. Okay, sorry. All right. Now we don't actually have to graph though. We just need to list them. And again, I wouldn't say the order matters, but I guess it does. So what did they do here? Let's look at number 2, part A. Well, the original, I'm going to call it the OG, was just root x. So what have they done to this? Well, this negative is going to be a reflection over the x-axis. This 3 on the outside is going to be a vertical stretch by a factor of 3. This 2 on the inside is going to be horizontal compression by a factor of 2. And this -1 dangling at the back is going to be down 1. So a vertical translation or slide of down 1. If your teacher's not uptight, you could just put down 1 probably. All right, let's look at that. So here is our original square root x. And we had -3 square root x. So there's the, first of all, here's just the reflection over x. Now I'm going to put the 3 in. You'll see it gets skinnier. And then I'm going to put the 2 in. Ooh. And then I'm going to go -1. I'm pretty sure that's right. Definitely the -1 part's right. Definitely the reflection is right. And the stretching and stuff, it's just hard to see sometimes. But I think it's okay. And this vertical, the orange one, the horizontal compression, it might be by a factor of half. You might take the reciprocal of that one. So it's like got half squished. Again, that's just hard to see, but I'm pretty sure it's right. Right. I really wish I had an answer key on this, but it's okay. All right, let's go to B. All right, so what's the parent function on B? Or I'm going to call it the OG. It looks like it's x cubed. And then what did they do to that? Well, this 1/3 on the outside would be a vertical compression by factor of a third. And this 1 on the inside is going to be a horizontal slide or translation. It lies. So you would think +1 horizontally would take you to the right. That's a lie. So it's going to go to the left 1. And that's it. Again, we kind of look at that one. This one might be a little bit easier to look at. So here's the original x cubed. And then we had 1/3 x cubed. So you can see on the new one, the red one, it got squished a little bit. It's not quite as steep. That is your vertical compression. And then we're going to take it to the left 1. There you go. You can see it got, no, skewed, excuse me, it went to the right 1 unit. Did we have plus or minus? We had plus. Sorry. There we go. Went to the left. And is that what I had? Yes. Alrighty, that one was a little easier to see than part A. Number 3. Write the function given the transformations. Okay, so we're starting with absolute value of x, okay? Expand horizontally by a factor of 2. Okay, that one's going to be the tricky part. Let's skip that. Translate right 1 and translate up 3. Okay, so that's definitely going to be a +3. Okay. Right 1 is going to be a -1 on the inside. And expand horizontally by a factor of 2. It's either going to be 2x right there. Horizontally means it's with the x, not on the outside. Or this could be a half. This is the one where it's either it's the real thing or it could be the reciprocal. I can never remember, but I can figure it out. Absolute value button of x. Okay, there's the original. I know the 1 and the 3 are right, so I'm going to put those in first. Absolute value x -1, so that definitely took it to the right 1, and then +3, definitely going to take it up 3. So those parts are right. Right 1, up 3, for sure. Now we want to expand horizontally. So we want our new one, the green one, to be bigger. So let's see what this 2 does. No, that made it skinnier. So let's make it a half. Yes, there we go. So horizontally expand, we need to do the reciprocal. So let's make this a half. There we go. Let me just rewrite that neater. It would be absolute value 1/2 x. Okay, again, that's the expand horizontally. This one you do the reciprocal. Minus 1 would take you to the right one. Close the absolute value plus 3. All right. Horizontal is where you have to do the reciprocal. So now that we know that for sure, come back up to number 2, please. This one should be horizontal compression by a factor of 1/2 because that's the reciprocal. The rest on whatever I put for 2a should be right. But this horizontal thing needs to be the reciprocal. Okay. And now I'm going back down to number 3, the second one. Oops, sorry. It looks like we're starting with the function is root x. Stretch vertically, reflect. Okay, this one's easier because it's a vertical. You don't have to do the reciprocal on this. So root x. The reflection is a negate in the front because it's x-axis. The vertical is a 3 in the front. You do not need to do the reciprocal. Right 2 would be -2 because again, you think here's 0. You think right would be +2, but it lies. It goes the other way. And down 3 would be -3. Make sure that's out of the function. Okay, I'm sure on that one. Horizontally goes with the x. This vertical goes on the outside. And again, the horizontal one, you have to do the reciprocal. Okay. There's the first page of 14. That is not my favorite topic, but hopefully we're done with that. Yes, we are. Okay. Let me zoom this one out a little bit to get all the pieces. Goodness, that is a long question. Okay, great. Let me zoom out just a little bit more to get all the pieces. I think it went down a little further. Okay. List the intervals for which this function is increasing. So we're kind of going to do A and B at the same time. Start at your left and pretend like you're on a roller coaster. Up, 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 up. Stop. And when you say that's like -2.5, so from the very left to about -2.5. All right. And then get back on your roller coaster. Down, 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 down. Stop. Would you say that's like -0.5? And you're only looking at the x, by the way. So that was from the x value of -2.5 to about -0.5. And then get back on the roller coaster. Up, 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 up. So do a U that stands for union, just a math symbol for and. -0.5, because again, you're only looking at the x to forever. And again, those aren't like perfect. That one certainly does look like -2.5. And this one, I wouldn't say this one's smack on, but it's not, I don't think. Yeah, let's just say -0.5. That's not perfect, but good enough. Okay, so list the intervals for which the function is negative. So that's anything under the x-axis. So from your very left to here, so your very left to -3, and then from -2, that's still under to 1, and -2 to 1. That's a comma. Okay, positive is when you're above the x-axis. So here, -3 to -2. And again, you're only looking at x values for this. And 1 to forever. Okay, so this was above the x-axis. This was below. And the increasing and decreasing. Increasing is when your roller coaster is up. and decreasing is when your roller coaster is coming down. Relative maximum, that is a high bump. So right there. I would say that point is at -2.5 up 1. Relative minimum, that's your low bump. So again, this one's going to be a little bit of a guesstimate, but that's okay. I think right there ish, I'd say -0.5, and then it's like down 6 is our low bump, our minimum. List the range. So how high up, how low down. So this goes down forever, and this goes up forever. So you could either put all reals or -infinity to infinity. Domain is left to right. This one's going to go left forever as it goes down. This one's going to go right forever as it goes up. So left forever, right forever. So all reals or -infinity to infinity. Find the value of f of 0. So when x is 0, what is y? So here, I mean, it's close to -6. I wouldn't say it's spot on. Let's zoom in a little bit. It's almost -6. I'm going to clear this off, so pause me if you need that stuff. It's like just a smidge above -6. I'd say like -5.8. So f of 0 is like -5.8-ish. Like that's my ish. It's super close. Probably if you put -6, they count it, but it's a smidge above that, but not by much. That was I. Find the value f of -4. F of -4. So that's x is -4. Boop, 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 boop. Like -5.5 ish. Again, that's an ish. I think. Let me kind of do that one again. See, I don't know if I'm staying straight. Let me change my tool to this line. Ugh. I don't know. It's hard to tell without like graph paper. Let me zoom in even more. -4 right there. It's hard to tell. Sorry. It could be more like -6.5. Yeah, let's go with that actually. So f of -4, approximately -6.5. Again, that's not perfect. It's okay. It's fine. Good enough. If they don't give us good graph paper, then that's what they're gonna get. And I think there was one more. For what value or values does f of x equal 0? So when is y 0? So this is the last question. F of x equals 0 for what values or value? Right here, right here, and right there. All right, that one's for sure right. And that was the last letter, whatever it was. So this means f of x equals 0. That's y equals 0. So basically, we're looking for our x-intercepts. All right, some of those, again, were like a little guesstimate-y, but that's what you're going to have on these, especially if they don't give you like a grid. So it's fine. All right. Piecewise, graph the piecewise function and then answer the questions. Okay, so use a pencil here and just graph this. So that's like y equals x plus 3. Don't look at the next part. Very lightly, that would start on 3, right? And that has a slope of 1 over 1. So up 1, right 1, up 1, right 1, or down 1, left 1, down 1, left 1. And that's how you know you would normally just graph this line. Connect your dots very lightly, arrows on both sides. Okay, but this was for if x is less than -2. So come on your x to -1, -2, connect, open circle, because it does not have the equal and it's less than. So you're going to keep your left. Keep that left-hand arrow, erase the right. Okay. I call this the eraser method. Alrighty, let's come to the middle one, x squared. So again, just graph it. Y equals x squared. That's a parabola that starts at the origin. 1 squared is 1. -1 squared is 1. 2 squared is 1, 2, 3, 4. -2 squared is 1, 2, 3, 4. And then it would, be a parabola. Arrows on both sides. But that was only true for -2 to 1. So we're going to come to -2, 1, 2, connect, solid, because this does have the equal. Come over to 1, connect, open, because it does not have the equal, and then just connect those two. So only this little bit of the parabola lives. Erase the rest. Right, and finally coming to this one, back to a line. So that's really y equals -x plus 2. So that's going to start up 2. And the slope is -1 over 1. So down 1, right 1, down 1, right 1, down 1, right 1, down 1, right 1. Connect. But that was only correct if x is greater than or equal to 1. So we're going to come to 1, connect, close, greater, keep your right-hand side. Erase the left. So that open dot from the middle part did get colored in. That sometimes happens. We'll take it. And there we go. There's your graph. Is the function continuous? No. We have to pick up our finger or pencil. So no, not continuous. Where does the discontinuity happen? Right here at this open dot, and then we would jump to that closed dot. So that's at x equals -2. So we have a discontinuity at x is -2. Now, again, this one was an open dot, but it got filled in. So that one's okay. Evaluate h of -2. So come on your x to -1, 2, and find the solid dot. So that's up 1, 2, 3, 4. Evaluate h of 1. So come to 1 on your x, find the solid dot, which is up 1. And h of -5. So 1, 2, 3, 4, 5. Find your dot, 1, 2. Down, 2. And there we go. Those are hard. They take practice. Watch that back through a couple times if needed. If you're allowed Desmos, real fast, let me show you how to do that on Desmos. Squiggly bracket, x plus 3, comma, and then, wait, hold on. Just do x plus 3, and then squiggly. X was what? Less than -2. There he is. Now you can't see the open dot until you click and it'll say undefined. It's sometimes very tricky to get it. Let me zoom in even more. Sometimes it's just very annoying but there is an open dot there. Desmos is not the best with showing it. And then what was the next one? It was like x squared, squiggly bracket. And then that was from -2 less than or equal x less than 1. There it is. There's the part of the parabola. And then our last one was like -x plus 2, squiggly bracket. And that was x greater than or equal 1. There it is. So that's how you can do that on Desmos. Not that you need to, but you could. All right, that was page 2. Page 3. Use the graph. Okay, so let me zoom out. Okay, just goes through F. Is this function continuous? If not, state. It is, because you would not need to pick up your pencil. It is continuous. Yes. So we don't need to worry about that part. What's the domain? How far left, how far right? So left looks like -3, right looks like 4. Solid bracket -3, solid bracket 4, because it closed dot on both of those. What's the range? How low, how high? How low? -1, solid bracket. And how high? 4, solid. All right, increasing. We're going to ride the roller coaster. So we're actually going to do like D, E, and F all at the same time. So start on your left, down, 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 stop. So that's going to be decreasing. So from -3 to actually do a soft bracket on those. We just typically do to 1. Okay, keep riding that roller coaster. Up, 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 up. So that's increasing 1 to 2. And again, you're only looking at your x values. And constants, where you're just walking straight. 2 to 4. And again, typically on increasing, constant, and decreasing, we use soft parentheses no matter what. That's just what I've always done. If your teacher says differently, follow your teacher, but that's what I do. Okay. So decreasing was the blue, where we're going down, only looking at your x values. So that was x here to x here. Increasing was green, so from 1 to 2 on the x, and constant was orange. All right. Use this graph. Is it continuous or not? No, we would have to pick up our pencil. So no, not continuous. You'd have to pick up your pencil here at -2. So it's discontinuous at x equals -2. And here, you'd have to pick up your pencil at x equals 2. Right? Evaluate h of -2 plus h of 2. Okay, so let's get -2. So 1, 2, go to the solid dot there. So 1, 2, 3. So this part's -3 plus h of 2. 1, 2, go to the solid dot, so that's up 1. -3 plus 1 is -2. What is the domain? How far left, how far right? So this is the farthest left, which looks like it's at -5. So we will do a solid on -5. And then it goes here to -2, open, but that gets closed. Goes here to 2, open, but that gets closed, so we're okay. And then it comes over here to 5. That's the farthest right. So we do not have to break that, even though it's not continuous, as we discussed in part A, because these open dots get closed in for the same x, it's okay. What is the range? Okay, so how far low? Well, this whole thing right here is just down 3. So -3. And then this goes low to 0. So this is like 0 to 4. And then this one's 1 to 5, right? So that one's 0 to 4, but then this one's cut. Yeah, yeah. And that's 1 to 5. So let's go 0 solid to 5 solid. Why did I not have to split that? Because even though this was open, it got closed with the same Y. So it's fine. And then this was closed. Okay. So again, this one was really 0 to 4. This one was 1 to 5. But because the open dot got closed on the same Y, you're good to just go 0 to 5. I know that's a little confusing. Again, and these just kind of take practice. And these last three we'll kind of do all at the same time again. Increasing, decreasing, and constant. Let's do the constant first. It's from -2 to 2. But again, let's just do soft. That's how I just always do those. Even though we've got a close and an open, it's okay. That's your constant because that's you're walking straight. This one, down, 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 stop. So decreasing from -5 on the X to -3. And then up, 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 up. So that's -3 on the X to -2 and up, 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 up from 2 on the X to 5. So that one did need to split because it had two different parts going up. Okay, just practice that. I think those are all correct. Just practice them. If I made a mistake, let me know in the comments. Okay, that was page 3. The graph above shows the weeknight rates for a parking garage in downtown Richmond. Use this graph to answer the following questions. Let me zoom out a little. All right, that is a piecewise function. All right, what kind of function? It's piecewise. Piece, this is how you spell it, piecewise, or this could also be called a step. Actually, that's probably better. Step function. Step function is a particular piecewise function that looks like stair steps. See how this kind of looks like steps? You could walk up, up, up. So either piecewise or step might be a little better. Write the equation for the graph. Okay, so f of x, or f of t, because you can see it's right here. It's given in time. All right, if you park from 0 to half an hour, right? So 0 to half hour, you are going to pay, I really wish that was smack on. What, 350? Because that's 2, that's 4, or would it just be 3? It's hard to tell. Let me zoom in a little bit. See, I don't think it's right in the middle. I'm going to go 350. If that's wrong, sorry. Oh, let me go back. Okay. So you're going to pay $3.50, I think, if your time in the parking garage is 0 minutes up to 30 minutes, but we're in hours, so we'll go half, including the half. Because see, this one's solid, not including the 0. Because if you're not parking, you're not going to pay. If you're parking for 0 minutes, you don't need to pay anything, right? Okay. But go up to the middle step. If you're parking from that half hour to 1 hour, you're going to pay what? $6. So 6 if your time is between half hour to 1 hour. And again, including the 1, because this has got the solid dot. Okay. But if you're going to park longer than that, if you're going to be there from 1 hour to 12 hours, so like overnight. So if your time is in between 1 hour all the way up to 12, including 12, you're going to pay $8. All right, what's the domain of this function? Well, it starts at 0, open dot. So we'll do soft 0 and it goes on the X or the T to 12. And is that solid? I think that's solid, yeah? Again, this is kind of bad. I did make a scan of this, so this could be my fault. I think let's assume that one's solid. So let's go 0 to 12, solid on the 12. What is the range? It's just those three values. The only y's this thing hits is 350 and 6 and 8. That's it. Those are the only y's that are possible for this parking garage. All right, I don't enjoy those. Hopefully that's all good. These next ones, I don't mind. Solve the equations by using one of the following. We can factor, quadratic formula, or completing the square. So because it doesn't say you have to use like which one, do whatever is easiest. So to me, factoring out of those three, factoring is always going to be the easiest, but it doesn't always work. Let's look at 9. Let's see if it factors. Check for GCF. No greatest common factor. I'm going to factor with the magic X. If you factor differently, go for it. I take the first number times the back number, so that'll be 24, and I put the middle number here. What multiplies here adds here. Yay, this one does factor. So 8 times 3. Set up your two factors. Positive 8, positive 3. See this x squared? Cut it in half. 1x for me, 1x for you. But if you like foiled those two red ones back, it wouldn't work, right? Because x times x is x squared. We had 2x squared. So really, when we do this 2 times 12 to get this 24 for the magic x, this is cheating. So the multiplying this 2 is cheating. So how do we uncheat it? You divide under your magic numbers 2. You only have to do this step if this first number is not a 1. So this one's not a 1, so we have to uncheat. So 8 divided 2, that would just be 4. And this one, we're just going to leave x plus 3 halves. And see it equaled 0. So now set both of those equal to 0. So x plus 4 is 0. So this would be negative 4. And set this to 0. This would be negative 3 halves. If you graph this, you would see a parabola hitting at negative 4 and negative 3 halves, or negative 1.5. So that did factor. If you don't like to factor, you don't have to. Right? You could have also done the quadratic formula. I do not recommend complete the square. All right, that one did factor though. If you factor differently than me, go for it. Just make sure we get the same answers. Now look at the number 10. I do not think this one's going to factor. We can try. I make my magic X. I put in this 1. This would be negative 1 and 5. What multiplies here adds here? Nothing, right? It won't factor. So I'm going to do the quadratic formula because I really do not like complete the square, and I really don't recommend complete the square when this middle number is odd. It works better when that middle number is even. So I'm not going to complete the square. Let's quadratic formula. I would have this memorized if I were you. Let's put in this invisible 1. This is A, this is B, this is C. Negative B plus or minus big square root b squared minus 4ac all over 2a. So we're going to have negative 5 plus or minus big square root 5 squared minus 4ac, so 1, negative 1, all over 2 times 1. But 2 times 1 is just 2, so there we go. If you're allowed a calculator, shoot this inner part through the calculator. So now that's going to be negative 5 plus or minus big square root 25 plus 4, which is better known as 29, all over 2. And that's going to be our answer, because usually we would try to break down the root, but 29 is prime, so it would not break down. We're done. Okay, x squared plus 5x minus 1. Here's how you can check that. X squared plus 5x x minus 1. Okay, and we got negative 5 plus square root, plus square root 29 all over 2. Is that what we hit? Say x equals. Yes, that's correct. And then I'm just going to change this plus to a minus, and boom, we're correct. You don't have to check it, but that's how you could. You could have checked number 9 as well. I just didn't. So 10, I used quadratic formula. 11, check for a GCF. No, try to factor 6. What multiplies to 6 adds to negative 12. It's not going to factor. All right. This one, you could do complete the square because this one's even. So I guess I will, just for kicks and giggles. I would probably, in real life, like if it didn't have that as an option, I would just do quadratic. So I would do exactly what we just did for 10. And maybe I will. But let me do to complete the square first. You're going to move this naked number over. So that's going to be 3x squared minus 12x equals negative 2. You want this to be a 1. So we're going to factor a 3, which will leave x squared minus 4x, right? Because we factored a 3. And then do a plus blank, and this still equals negative 2. And then what goes in the blank is you take this middle number, so negative 4, and you chop it in half, so negative 2, and you square it, so 4. So middle number, chop in half, square. But if you distributed, that would really be a 12. So we really just added 12 right there. Right? So we're going to add 12 on the other side to keep the balance. So now on the other side, negative 2 plus 12 would be 10. And on this side, we'd have 3 something squared, because that's why it's called complete the square. So let's factor this trinomial. I'm going to magic exit up to the side in blue. There's a 1. So that's 4 and negative 4. What multiplies to 4 adds to negative 4. Negative 2 times negative 2 would be positive 4 when you multiply and be negative 4 when you add. So that would be x minus 2 twice. Solve. Divide 3. So we get x minus 2 twice equals 10 thirds. Take the square root. Take the square root. Take the square root. So that would be x minus 2 equals plus or minus. Bounce this off the bottom. So that would be square root 30 over 3. And then just move this 2 over. So x is 2 plus or minus root 30 over 3. But that's ugly. So you probably put a 1 here and you get a common denominator. So you times this by 3. So I would say x equals 6 plus or minus root 30 over 3. Does 30 break down? Yes, it's 3 times 10, which is 2 times 5, but there's no partners, so it doesn't simplify. You're good. I think answer. That was using complete the square. I just think I don't like that method. So I'm now going to do 11 again, quadratic formula, and see if we get the same thing. This is A, this is B, this is C. Negative B plus or minus big square root b squared minus 4ac all over 2a. Now careful, our b is already negative. So it's really negative 12. Plus or minus big root negative 12 squared minus 4a, which is 3, c, which is 2, all over 2a. So 2 times 3. Okay, but negative, that's really going to be 12 plus or minus, and on the bottom, 2 times 3, that's going to be 6. And then big root, if you're allowed a calculator, push that in the calculator. That would be 144 minus 24. But that's really 120. So I'm going to just use some whiteout. Okay. Let's see if 120 breaks down off to the side. That would be 12 times 10, but 12 is 2 and 6, and 10 is 2 and 5, and 6 is 2 and 3. So I do see a partner of twos. So that would be 12 plus or minus 2 root, who did not have a partner. Only looking at your primes, by the way. So 5, 3, and 2. Multiply that all together. 5 times 2 is 10, times 3 is 30, all over 6. And then ignoring the guy in the root, he's fine. This is even. So you can divide by 2, which will just cancel, and divide by 2. So I'm getting a final answer of 6 plus minus root 30 all over 3. And that is what I got the other way as well. I just think the quadratic formula is easier. Okay, done. That page. My pen is starting to be weird again, which is so frustrating. I'm sorry. I don't know why. All right, answer the questions below to help graph the equation by hand. Write it in vertex form. Save the vertex. Okay. Let me zoom out a little. All right, so to put something in vertex form, we do usually need to go ahead and complete the square. So I'm kind of glad I already showed you that process, but I will show it again. So we're going to have x squared minus 2x minus 2 equals set to 0, and then move your constant over. So that's going to be x squared minus 2x plus blank equals, move this over, and that'll be a 2, and then plus blank. This is already a 1, so we do not need to factor anything out like a GCF like we did in the previous question. So what you do is you take this middle number, so -2, I'm doing it to the side in blue. I don't know why my pen is starting to act up. Sorry, 1 second, please. Sorry, got a message from someone I need to respond to real fast. Sorry about that. I'm trying to troubleshoot the pen and let me do one thing here. Nope. Okay. All right. Anyway, so you take that middle number off to the side, cut it in half. So that would be -1 and square it. So that would be 1. So you're putting 1 here. And see, this time you're not distributing anything. So you just need to put a 1 there. Okay. So on the other side, 2 plus 1, of course, is 3. And on this side, this should factor. So I'm coming to the side, still in blue. 1 times 1 is 1. Middle number is -2. We need to multiply here, add here. So what multiplies to 1 but adds to -2 would be -1 and -1, right? Negative times negative would be positive. -1 plus -1 is -2. So this would be x minus 1 twice. Ugh. 1 second, please. And then move this back over. So final function here in vertex form is going to be x minus 1 squared. I'm so sorry for the pen. Like literally, I bought a new computer last week and it still doesn't work. And then this 3, when he comes over, that would be negated, right? That is our function in vertex form. All right, so the vertex is this number and this number, but the first one with the x lies. So see how that looks like -1? It's actually 1. And the second one, though, just tells the truth. So that is -3. Okay, so let's graph that. Come down to the graph. We're going to come right 1, down 1, 2, 3. Okay, find the y-intercept. I'm going to skip part C for a second. Find the y-intercept. You can go back to the original equation and just plug in 0. So y equals, and then that would be 0 squared minus 2 times 0. Oh my gosh, this pen. Minus 2. Well, 0 squared is nothing. 2 times 0 is nothing. And you're left with just -2. So your y-intercept, if we plug in 0, we get -2. Oh my gosh. I can't write a 2 to save my life. Oh, or a parenthesis. That's great. So go over 0, down 2. So that brown point there is our y-intercept. All right, I'm trying to switch pens here. See if we have any better luck. All right, I'm gonna have to pause the video and pick it back up in a second. So hopefully for you, it'll be no pause, but I'll be right back trying to troubleshoot the pen. So guys, I'm gonna start a part 2 and I will just restart number 12 in that part 2, still trying to troubleshoot the pen. So this is gonna conclude part 1 of the midterm study guide. There will certainly be a part 2. So this had the first 4 pages on it, and I'll just start number 12 fresh on part 2. All right, we'll see you soon for part 2. Bye-bye.